we are doing regular graphing and this and trig stuff. Okay, so kind of putting that together. The good news is trig graphs are not a huge part of calculus. You do not have to be good at this. For more than anything else, it's, hey, are you good with the unit circle on this front page? That's what I'm trying to figure out. All right, so if I had a graph right here and I was trying to do sine, I'm doing sine at each one of these things. So at 0, pi over 2, pi, and so on. All right, so if we're doing sine, let's start off at 0. You got to know what the ordered pair would be at 0. It'd be 1, comma 0. So if I'm doing sine, what do I care about if I'm doing sine? The y value. What is your y value going to be at 0? It's 0. So we put 0, 0. There's a point. Pi over 2. Pi over 2 would be the top of my graph. That right there is pi over 2. It's the ordered pair 0, comma 1. What's sine going to be? 1. So at pi over 2, I got a dot at 1. Then I would go over here to pi. At pi, it's this ordered pair right here. I'm doing sine, so the y value is 0. 3 pi over 2. I'm down here. The y value is negative 1. And then we go back around. There is my sine curve. Sine curves start in the middle. They work from there. If you can remember that, you'll do well. Okay, a little bit different than cosine. If I'm doing cosine, I'm starting right there again. What am I thinking about when I'm doing cosine? Cosine means what to us? The x. Thank you all for being so engaged. It's the x value. It's a 0. Okay, so we're starting. I'm just kidding. That's not an x value anyways. You guys throwing me off. I can't even know what x and y is. It's 1. So it's 0. We got 1. At pi over 2 up here at the top, my x value is 0. At pi over here at the left, my x value is negative 1. 3 pi over 2 down here at the bottom, my x value is 0. At 2 pi, I'm back to the top. There's my cosine graph. Questions with that one? Cool. Let's do tangent. Take a second and see if you can figure that one out without me just doing it for you. We're doing tangent at 0 right here. If I'm doing tangent, what is tangent going to be for us, Caden? Tangent means what? X over y, y over x? Y over x. Tangent's y over x. So if I'm right here and I'm doing y over x, what am I going to get? 0, because it's 0 over 1. That is 0. So right here, we're going to have a dot at 0. Okay, pi over 4. Pi over 4 is not even on my graph. If I'm doing pi over 4, I'm right here at pi over 4. Okay, Evan, what am I going to get right here at pi over 4? And square root of 2 over 2. It's that order pair right there. So if I did y over x, what's that going to get me? 1. At pi over 4. So right here, I'm going to get 1. Because it's root 2 over root 2. That gets me 1. So I got that right there. At pi over 2. If I wanted to go at pi over 2. So right here at the top, it's this ordered pair. 0, comma 1. Sophia, what's tangent going to be there at 0 if at the ordered pair 0, 1? Good. So what does that mean for us? Wonderful. It is undefined right there at pi over 2. So she is going to draw an asymptote line right there. Okay. At negative pi over 4, that would be this guy right here. What would tangent at negative pi over 4 be here, Zachary?
I'm sorry, what?
Negative pi over 4.
Oh, that'd be radical 2 over 2.
Mm-hmm.
Negative radical 2.
Good. And a negative radical 2 over 2. So what's tangent going to be?
Negative 1.
Negative 1. Good. So he's at negative 1 there. And then the same thing's going to happen there at negative pi over 2. We're going to get an asymptote. That is why we get this graph right here. All right. Do you have to be an expert at making a table and filling it in? No. I want you to know what the graph is, but I also want you to know why it's happening. There's a reason why there's asymptotes when you have tangent. It's because we're getting 0 in the denominator and we're making it undefined. This thing would keep repeating forever and ever and ever, but I don't have time to make the whole graph. But I understand what's going on with the first one? Cool. Let's get to the next portion. So the next portion, we're graphing some stuff. We are doing simple transformations, okay, simple shifts to this graph. I like doing this as quick as possible, so I like to memorize some rules that will help me out here. Okay, so everybody show me with your arms, what is x plus 4 squared? What's the general shape going to be on that graph? It's squared, so it's a parabola. Yeah, good. It's a parabola. Point with your finger. Which direction is this +4 going to move my graph? All right, so we got some ups and some lefts. It's inside parentheses. So if it's inside parentheses, it's either going to take me left or right. If it says +4, which way is it going to take me? Left. That thing's taking me left. Okay, so that that's not left. That's left. Sorry, I was pointing the right way. Takes me to the left 4. So right here is where my vertex is going to be. It shifts me to the left 4. It's a parabola. Okay, so your pre-calc teacher might have taught you a little bit differently. I like doing this quickly. And so I use the shortcut 135. Okay, here's what that means. It's just the way to make a graph. From that first dot, I'm going to go up 1, over 1 in both directions. Then I'm going to go up 3, 1, 2, 3, over 1 in both directions. And then 1, 2, 3, 4, 5, over 1, 5 over 1. That just allows me to quickly sketch out a proper parabola. Okay, if you don't believe me on that, plug in -1, and when you plug in -1, you get 9. Okay, but just memorize that 135 pattern, speeds up the whole process. Questions on number 1? Number 2 says 2, absolute value x plus 3. Show me with your arms. What's the shape going to be? Absolute value, so it's a V. Point. Which direction is that +3 going to take my graph? +3 tagged on the end, so it's going to take me up 3. So there's my starting dot. I got a 2 in front. What is that 2 going to do to my shape? Yeah, it's going to stretch it vertically. That's a vertical stretch, and so it's going to make that V a little skinnier. Okay, when you have a number in front of your absolute value signs like that, treat it like slope. Okay, that 2 is making me go up 2 over 1, up 2 over 1. That is the main idea of that graph. If you didn't remember, you could always plug in some numbers and see what you get. Again, memorization makes these things go a little bit faster. Everybody good there? Number 3 says negative square root x minus 2 plus 3. Show me with your arms. If it just said square root, what's that shape going to look like? If it just said square root, it's this shape right here. It would be that guy. That's a square root. But it's negative. Show me with your arm. What does a negative do to your graph? It's a vertical flip. So instead of being up like this, it's going to not be a teapot anymore. Now it's a water slide. Okay, so my shape is going to look like that now. You got a -2 point. Which direction is the -2 going to take your graph? -2 takes me to the right 2. The +3, it's tagged on the end, so that's going to take me up 3. So right 2, up 3, that's my starting dot. It's that weird teapot that's been flipped upside down. My pattern is 1, 3, 5 still. Square root and a square, they both have the same patterns, just treated in a different way. So I'm down 1 over 1, and then down 1 over 3, down 1 over 5. There's my graph like that. Basic transformations, we'll do those a lot all year long, but for the most part, it's more of, hey, don't forget about this. Questions through 3? On your paper, you have a 4, 5, 6, and 7, or 4, 5, and 6. Those are all factoring problems. We did them yesterday. I switched which day we taught them on, so we don't need to do those today. Okay, let's look at number 7. Throw that thing inside of parentheses there. Don't let that be weird with the negative sign. Cosine at -pi/3. All right. You can do these if you can do them in your brain, great. I struggle to do them in my brain. I always draw a little picture. Okay, so just like we were doing on the front side, I'm gonna make a little XY graph. Show me with your hand which finger represents pi/3. Which one's pi/3? The first, second, or the third line?
Third.
The third one. It's not this one. It's that guy. That's pi/3. Okay, so if I'm doing the hand trick, pi/3, my x value is 1/2. My y value is radical 3/2. That doesn't tell me -pi/3. That tells me pi/3. Where is -pi/3 going to be located? Down in the fourth quadrant. So that line right there really matches up with that line right there. Okay, it's really that guy. What's going to be different about this point in the fourth quadrant? Negative y. The y is going to be negative. Negative radical 3 over 2. Okay, so I've got that set up. I'm doing cosine. If I'm doing cosine, which one of these two numbers do I want? Do I want the 1/2? Do I want the x? Or do I want the y? X. So my answer is 1/2. Do you have to draw everything out? No. But if you're not good at it, draw everything out. There's number 7. Number 8 says secant of 2 pi over 3. Secant of 2 pi over 3. So same thing. I always start off and recognize which finger is 2 pi over 3. Okay, well, I know that pi over 3 is that guy again. Okay, that's pi over 3. It's the same ordered pair we did on the last one. So the ordered pair is 1/2, comma, radical 3 over 2. Which quadrant is 2 pi over 3 going to be located in? The second one. It's going to be that guy right there. That's 2 pi over 3. What's going to be different about that ordered pair here in the second quadrant? Negative x. I'm doing secant. Secant goes with cosine. It goes with the x. I'm taking that thing right there, but I'm doing secant. Show me with your fingers. What is your answer going to be on this one? Show me with your fingers. What's your final answer going to be? Negative 2. Right? You got negative 1/2. You reciprocal. It's negative 2. You hold it upside down. I know you mean negative. Negative 2 there. Everybody good there? Let's switch from 300. Let's make it 330, just because I'm tired of doing the same numbers over and over again. No, I lied. Nah, keep it 300. Because there was something else I want to do. All right, cosecant 300. Boom, boom. I don't know where 300 is. In the top of my brain, I kind of struggle just visualizing it. What I do know is it's 60 less than all the way around. And so if I drew what 60 looked like, oh, guess what? Same ordered pair. Okay, same ordered pair there. I want 300. So instead of being up there, I'm really going to be down here. What's going to be negative? The y value. I'm doing cosecant. So which do I want, x or y? The y. So cosecant. What do I need to do with that thing? Flip it. It's not right. What do you mean it's not right? Yeah, remember in PreCalc when we had to rationalize the denominator? We do not care about that at all in calculus. You never have to rationalize denominators. Yep, for nothing. Absolutely nothing. It means zero. It's garbage. Don't rationalize denominators in calculus because we don't care that much. We're worried about the calculus and not about dumb things like rationalizing the denominator. It's not fun. Don't do it. All right, let's do the next 3 there. Try 10, 11, and 12. Just treat 10 as 2 separate problems. Don't add them. It gets really ugly. But do 10, 11, and 12 there. See what you can get. Cosecant of pi over 3. We're doing cosecant of pi over 3. Paige, what'd you get for that one? 2. Careful. You got to flip the y value. So that's the same one we've been doing. So we're flipping radical 3 over 2. So if I flip radical 3 over 2, what's that going to end up with? Yep, there you go. Cosecant is 2 over radical 3. An ugly answer, but that's fine. Tangent of 3 pi over 4. So if I'm doing 3 pi over 4, now I'm looking at this ordered pair right there. Austin, what do you think on that one? Negative 1, because if I'm doing 3 pi over 4, that's radical 2 over 2, radical 2 over 2. And if I'm in the second quadrant, the x is negative. So if I put them on top of each other, it'd get me negative 1. Good. We could add those. I didn't ask you to do that, though. 765. Is 765 on my unit circle? So subtract. I'm going to get rid of 360. If I get rid of 360, I'm left with 405. Is 405 on my unit circle? So subtract. I subtract again. I get 45 degrees. If I'm doing tangent at 45 degrees, hold down that middle finger. It's y over x. What's that going to get me? 1. Tangent of 45 degrees is 1. It's radical 2 over radical 2. Sine at 270. If I'm doing sine at 270, here's a graph. Here's 270 right there. If I'm doing 270, Kylie, what's sine going to be at 270? -1, good. And if I'm doing cosine at -60, we did that one just a second ago. Cosine at -60 is going to be that thing right there, 1/2. So -1 times 1/2 is -1/2. Question 212. All right, last thing of the day. Okay, last pre-calc, and then we get to actually be calculus students in here. Let's work through this last part. Okay, an important part because it might be something you've forgotten. Solve the equation. We're trying to get theta by itself, and we are solving it on this interval, and that interval means a lot here. Okay, first of all, it tells me my answer needs to be in radians, and I need to find every answer between 0 and 2 pi that's going to make this true. Okay, I'm trying to get theta by itself, so here's theta. Just like anything else, I'm trying to get it by itself, so I'm moving stuff over. What can I move first? Subtract radical 3, subtract radical 3. So 2 sine theta equals negative radical 3. Once I've moved that over, what could I get rid of next? 2. Divide by 2, divide by 2. That goes away. I get sine of theta equals negative radical 3 over 2. Next thing I need to do is get rid of sine. What is the opposite of sine? No, that's the reciprocal of sine. That's what we always want to say. Inverse sine. The opposite of sine is inverse sine here. So I'm going to take the inverse sine of both sides. Okay? And you might not even realize you're doing what you're doing here. But remember, inverse sine means I'm looking for where is your y value negative radical 3 over 2. Okay? So if I'm thinking about this, where is your y value negative radical 3 over 2? Well, it's positive radical 3 over 2 at the same place we've done every other one, which is pi over 3. Okay, pi over 3, it'd be positive radical 3 over 2. Which two quadrants am I looking at for it to be negative? 3 and 4. I'm looking right here and right there. That's when it's going to be negative. So I know the denominator needs to be 3 because that's pi over 3, and that's when it's going to be radical 3 over 2. What is the denominator, or what's the numerator going to be in the third quadrant? 1 more than the denominator, so 4 pi over 3. What's the numerator going to look like in the second or in the fourth quadrant? 5 pi over 3. 1 less than double. Those are all the places. Again, this isn't magic. If I looked at the unit circle, oh, right there, the y value is negative radical 3 over 2 at 4 pi over 3. Right there, it's negative radical 3 over 2 at 5 pi over 3. They're real things. Okay, just a matter of understanding. Let's go to letter B. 3 minus 4 sine squared theta equals 0. I want to solve that thing. Jesse, what do you want to do first there? Sure. Subtract 3. Subtract 3. So we get negative 4 sine squared theta equals negative 3. Once we've done that, Oyen Catalo, what do you want to do next? Yes, ma'am. Divide by negative 4. Divide by negative 4. That goes away. Sine squared theta equals positive 3/4. Still got to keep going. I'm not done yet. Okay. A quick reminder that sine squared, sometimes that throws us off. Sine squared theta, that is the same thing as sine of theta squared. Those two things are the same. Okay. So what do you think I need to get rid of next here? I got to get rid of the square. How do I get rid of a square? Square root. I'm going to square root both sides. So over here, I'm just left with sine of theta because those two things are going to cancel. I need to take the square root of 3/4. What is the square root of 3? Square root of 3. And what's the square root of 4? 2. So it is the square root of 3 over 2, but that's not right either. I'm missing something. Plus or minus guy took a square root. Okay, this is as advanced as we can get. Now we're solving. I'm doing inverse sine. I want to get rid of sine. I'm doing inverse sine. Whee. Theta equals. Now I'm looking for everywhere on the unit circle where your y value is either a positive radical 3 over 2 or a negative radical 3 over 2. Try to do that real quick. You don't have to look at a unit circle to necessarily do that if you're thinking it through. Denominator on everything's 3. It's a much different ordered pair that we've done so far. pi over 3 and 2 pi over 3 when it's going to be positive, and 4 pi over 3 and 5 pi over 3 is going to be when it's negative. Everybody good to that point? Let's try one more together here. 5 cosecant theta minus 3 is equal to 2. I'm trying to solve that. I got to move away piece by piece. Juliet, what do you want to get rid of first here? Sure. Good. Add 3 to both sides. So 5 cosecant theta is equal to 5. What can I do next here, William? Yup. Divide by 5. Divide by 5. Cosecant. Yeah. Cosecant theta is all equal to 1. This is a little bit your own personal preference. I don't like dealing with inverse cosecant. That's not something I can deal with. I'd much rather that be sine, right? If I make that sine, everything's a little bit easier. So I'm going to make this sine of theta over here. Well, if I make cosecant sine, it's because I did the reciprocal. I took the reciprocal of that side. So cosecant became sine. So if I do that to the left side, I got to do it to the right side. What is the reciprocal of 1 going to get me? 1. It didn't really do anything. If it said 2, then it would become a half. But here it's just going to stay 1. To finish, inverse sine. Inverse sine, I'm thinking about everywhere on the unit circle that sine is going to be a positive 1. How many places is sine going to be 1? Just 1. Up there at pi over 2. Right there is when sine is going to be 1, up at pi over 2. Make sense what we're doing there? Try letter D on your own. 4 secant theta plus 8 equals 16. We're trying to solve that thing. Evan, what'd you do first here on D? Subtracted 8. Then what? Divide by 4. So 4 secant theta equals 8. Divide by 4. Divide by 4. So secant of theta equals 2. Good. So we did the reciprocal. Cosine of theta equals 1/2. Then he's, go ahead. No, that would be radical 2 over 2. Okay, he's trying to figure out when cosine is 1/2. So cosine is 1/2. I want my x to be 1/2. Boom, boom, boom. Right there is when my x is 1/2. This is an ordered pair we haven't done yet today, but it's pi over 3. What's the, that was a joke, guys. Oh. We did a lot. That was the joke. We've done it a whole lot. Pi over 3. What's the other spot here where I want cosine to be a positive 1/2? 5 pi over 3 down there in the second quadrant, or in the fourth quadrant. Those are my answers. Questions on something we did today?